Good morning. For Mathematics 5, Quarter 1, Week 2. Divisibility rules for 4, 8, 11, and 12 to find the common factors of numbers. From the previous lesson, you have learned the divisibility rules for 3, 6, and 9 in finding the factors of large numbers. This time, you will learn the rules to determine if the numbers is divisible by 4, 8, 11, and 12. After going through this lesson, you are expected to use divisibility rules for 8, 4, 11, and 12 to find the common factors of numbers. The following table provides the divisibility rules for some whole numbers, divisible by 4. Method of testing numbers, the last two digits is divisible by 4 and number ending in two zeros. Examples, 348. So 48 is the last two digits. It is divisible by 4 because 48 divided by 4 is 12. So, therefore, 348 divided by 4 is 87. Next example is 812. So 12 is the last two digits of the number. So 12 divided by 4 is 3. Therefore, 812 divided by 4 is 203. Divisible by 8. Method of testing numbers. The last three digits is divisible by 8, 4, 2, and number ending in three zeros. Examples, 9,216. So the last three digits is 216 divided by 8 is 27. So therefore, to check, 9,216 divided by 8 is 1,152. Another example is 12,184. So 184 is the last three digits divided by 8 is 23. So therefore, 12,184 divided by 8 is 1,523. Divisible by 11. The difference between the sum of the digits in odd places and the sum of the digits in even places is 0 or number divisible by 11. Examples, 28,413. So the odd numbers there is 2, 4, 3, which is 9. And then the even places is 8 and 1, which is also 9. So 2 plus 4 plus 3, which is 9, minus 8 plus 1, another 9 is 0. So therefore, if you're going to compute 28,413 divided by 11, you will get 2,583. Another example is 35,794. So the odd places 3, 7, and 4. And the even places is 5 plus 9. So 3 plus 7 plus 4 is 14. 5 plus 9 is also 14. So 14 minus 14 is 0. So therefore, 35,794 divided by 11 is 3,254. Divisible by 12. Any number that is divisible by both 3 and 4. Examples, 7,980 is divisible by 3 and 4. 7,980 is divisible by 3 because if you add the digits, 7 plus 9 plus 8 is 24, which is divisible by 3. 24 divided by 3 is 8. For divisibility rule of 4, 7,980, the last two digits is 80 divided by 4 is 20. So 7,980 divided by 4 is 1,995. So it's divisible. So therefore, 7,980 divided by 12 is 665. So again, take note of the following. Divisibility rule for 4. A number is divisible by 4 if the last two digits form a number that is divisible by 4. Also, numbers ending in two zeros. Divisibility rule by 8. A number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. Also, a number ending in 3 zeros are also divisible by 8. Divisible by 12. A number is divisible by 12 if the sum of the digits of the numbers is both divisible by 4 and 3. Divisible by 11. A number is divisible by 11 if the sum of the digits in the odd places and the sum of the digits in the even places are equal or their difference is a multiple of 0. So let's try matry nga. Choose yes if the larger number is divisible by a smaller number and no if it is not. Can 5,367 be divided by 12? Yes or no? And the answer is no. Why? Because 5,367, if you add the digits, 5 plus 3 plus 6 plus 7 is 21. It is divisible by 3, but it is not divisible by 4. Can 4,884 be divided by 11? Yes or no? And the answer is yes. Because 4 plus 8 for even numbers and 4 plus 8 for odd numbers is the same. So 4 plus 8 is 12 minus 8 plus 4 is also 12, so it is divisible by 11. Can 85,000 be divided by 8? Yes or no? And the answer is yes, because 85,000 ends in 3 zeros. Our next topic is solving problems involving divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10, 11, and 12. In this lesson, you will apply what you have learned from the previous lesson about divisibility rules in solving word problems. After going through this lesson, you are expected to solve routine and non-routine problems involving factors, multiples, and divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10, 11, and 12. Study the problem and apply what you have learned in the previous lesson about multiples, common factors, and divisibility rules. Mang Jose needs to have blocks of woods that are 6 inches long each. He found logs of woods in their backyard that have the following lengths in inches: 44, 54, and 63. Which of the 3 logs is his best option to get equally sized block of woods without any excess? Which of the 3 logs is his best option to get the equally sized block of woods without any excess? To answer the questions, we need to recall the divisibility rule of 6. Then, we can eliminate options that are not divisible by 6. To solve this, the rule says that a number is divisible by 6 if the number is divisible by both 2 and 3. The first option, 44, is divisible by 2 because it ends with an even number, which is 4, but not divisible by 3 because if you add the digits, 4 plus 4 is 8, which is not divisible by 3. So 44 is eliminated. The other option, which is 63, is divisible by 3. However, it is not divisible by 2, so 63 is also eliminated. Lastly, we have 54. It is divisible by 2 since its ones digit is 4. Adding its digits, 5 plus 4 equals 9. 9 which is divisible by 3. Therefore, 54 is divisible by 6. So our answer, Mang Jose should choose the log of wood that is 54 inches in length since this will give him equally sized blocks of wood without excess. To check our answer, we can divide 54 divided by 6 is 9. Since there is no remainder, we are sure that there will be no excess woods after Mang Jose cuts the logs into 6 inches long each. Another problem. Choose the correct answer. Nigel made 18 bibingka. He arranged the bibingka on platters. With the same number on each platter, how many bibingka could Nigel have to put in each platter? Is it 3, 4, or 5? So the answer is 3. So Nigel can divide the 18 pieces of bibingka into 6 platters with 3 bibingka on each platter. Thank you very much.